Alright, let's make snake really fast. So we will create a new project, snake. Would you like to create source? No. Alright. So first thing we're going to add is a new HTML file. We'll call it snake.html. And we'll give it a title of snake. And in the body, we'll create a div. Let's actually create h2 tag, and we'll say score, and a span with an ID equal to score within it. And then underneath this, we will create a div, an ID of stage. Let's throw a style in here. Just one thing I think we need for this, and that is position relative. And that is going to make it so that our all of our grid or whatever we make for the game goes underneath the score and doesn't just go over top of it. So I think that is all for in the body. Underneath the body, let's just do a script include. Source is going to be snake.js, and this should be everything we need there. Let's create a new JavaScript file called snake.js. We're going to do this using classes. So we're going to create a game class, game, and each class is going to have a constructor, of course. And this one's going to take a width, a height, a size, and frames per second, just so we can easily adjust those. So this dot width is going to be equal to width, this dot height is equal to height, this dot size is equal to size, and this dot FPS is equal to FPS. Oops. Alright. We're also going to create the loop, or start the game loop. And we're just going to use a set interval for that. So we're going to call this value intval, or interval. So intval. We're going to set it to a set interval. And so the way we're going to have to do this to reference the instance is above here. Above it, let's just say var underscore this is equal to this, and that way inside of here we can actually run an instance method or something. So we're going to say 1000 divided by this dot FPS, and in here we will run this dot update. Now that is a method that doesn't exist, so we can just create that update, and for now there is nothing to update. So this will, when we create the game, constructor will run, and then we'll start ticking this update, or doing that at whatever frames per second we have. So one thing that I can do, just to make sure I don't forget it, underneath this, underneath the declaration of the class, we'll actually create the game instance, set it equal to a new game, passing in 25 by 25 by 25, so the size will be the size of the grid pieces, and then let's do it at 15 frames per second. So now we've declared our game class and created an instance of it. Next thing, let's create the render grid. So this will be, this will be a class that actually renders the game. So we could do this a few different ways, but we're going to do it like so. So the constructor. Oh, and one thing that I want to throw in to the constructor here, let's say this dot stage is equal to document dot let's say get element by ID, and let's grab the stage, and this dot, let's do score is equal to document dot get element by ID score, and we'll have this dot score val, and we'll set this to 0. So we'll have the actual DOM elements right there, and then whatever the value is, we'll use as score val. Now that we've got that, we can actually, in the update, one thing we can update is we can say this dot score dot inner HTML is equal to this dot score val. That way it'll be equal to 0, and then as our score increases, it'll just keep increasing on the front end. The constructor for the render grid is just going to take the game object itself, so we can reference all of the things within the game. Unused method. Constructor. Alright, so inside of this we're going to say this dot game is equal to, oh, this is supposed to be game in here. It's equal to game. And we will have this dot grid equal to a blank array. And what else do I need? Let's run this dot build grid. Alright, so this will be a method that we create now, build grid. We're actually going to build a grid or a multi-dimensional array and populate it with some values and some nodes. So we'll put in here a for loop. X var x is equal to 0. X is less than this dot game dot width x plus plus, and then we will say this dot grid at index x is equal to a blank array. That way we can populate that with the y. So for var y is equal to 0, y is less than this dot game dot height in y plus plus. And now that we're in here, we're going to say var node. We're just going to call them a node. It's equal to document dot create. I can do this right. Element. We're going to create a div, and we're going to set some CSS in here. So we'll say a node dot style dot width is equal to, let's do position first. Position is equal to absolute. So now we can position it absolutely within the stage. Node.style.width is equal to node.style.height is equal to this.game.size plus pixels. And node.style.top, or let's do left, is going to be equal to the x from the for loop multiplied by this.game.size. So we move it over a full grid piece. And node.style.top is equal to y times this.game.size plus pixels. We're going to give them a border, and that'll be 1 pixel solid. Let's do 7 times 7. Is that everything we need for the node? I believe so. Now we can say this.game.stage.append child node. Underneath this, now we're going to actually add the node to the array. So we'll say this.grid at x, y is equal to, and we're going to make this an object that contains a node, which we've just put in there, and then a value. And the default value is going to be false. And we'll use this value to determine whether we should fill in that grid piece with a black background or not. We will create a method called fillGrid. It's going to take an x and a y, and it'll be simple. We'll just say if this.grid x and if this.grid x y exists, then we'll say this.grid grid x y dot value. So we're going to reset that value equal to true. So if something runs the fill grid with an x and a y, we set that grid value, that grid piece value, to true, so that when we run this update, we'll say update here, we can actually you know, reset all of the grid pieces to show what pieces are have been filled in with this within this update. And you'll see that in just a moment. So first we'll say for var x is equal to, you know what, let's do some saving of time. Copy this, because we're going to loop through this exact for loop, but we're not going to reset. And this one as well. Alright, what we'll do in this one is say var node, we'll do it, no, grid piece, we'll say GP for grid piece is equal to this dot grid at x and y. Say if GP dot value, okay, is equal to true, then we'll do something, else we'll do something else. So if it's true, we want to fill it in as black. So we'll just say GP dot node to reference the DOM element dot style dot background is equal to black. Else we can set the background to white. And then once this is all done, we will take that same GP dot val and reset it back to false. So we're going to change the node piece's background to black or white, and then reset it back to false, so that the next update, if something fills in a different spot, the spot that currently was black will go back to white, because it doesn't need to be black anymore. Alright, so it looks like we've got all this done. Something is wrong here. So we've got the constructor. This is not back far enough. Oh, we forgot this one there. There we go. Got to make sure we close everything correctly. Boom, 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 boom. That should be good. So this right here, if we come down into our game constructor and we just say this dot grid is equal to a new render grid, passing this as the game object, and coming down to our update, we'll say this dot grid dot update. So we run the update for it. Let's see what we have here. If we run this and see if we got any. Oops, ran the wrong one. Run snake.html. Alright, so let's see what error we have. Unexpected token on line 25. Line 25. This needs to be closed here. And there. Alright, so that's closed correctly. Alright, so now let's run this again. And there's our grid. It is 25 by 25, but we do still have an error. This dot update is not a function. This dot update is not a function. Come down here and we need to run this dot update. There we go. There, now we're actually updating everything. You can tell because the score just hit 0. Let's proceed on. So now let's make something that's actually going to change the grid so we can see that working. And the first thing that we're going to make is a class called food. And this will be really simple. It'll have a constructor, of course. It's going to take a game object. This dot x. Oh wait, we won't even set that. We'll just say this dot place food. That's the first thing that it's going to do. we do need to have the game set. So this dot game is equal to game, and we will run a function called place food. So that we can rerun this, we'll have to make the function place food, and all it's going to do is say this dot x is equal to math dot random times this dot game dot width, and we need to wrap this and floor it. So we'll say math dot floor. Okay, and we'll do the same thing for y and height. Alright, so this is where this fill grid function is going to come into play. So we'll have an update for our food as well. And what that's going to say is this dot game dot grid dot fill grid at this dot x and this dot y. And it will fill grid every single time that we run the update function. So if we come down to the update of this before the grid, we can say this dot food dot update. So we actually have to create this food piece too. This dot food is equal to a new food, passing this in as the game object. And let's see what kind of result we have here. So it looks like there's a piece of food there, and there's a piece of food there, and so on. And it's updating its position based on random within the bounds of the world. Next thing that we can create now is the actual snake. One thing the snake needs is a class called parts, we'll say. And this will be parts of the snake, like little body pieces. So it's going to have a constructor, and that's going to take an x and a y. And it's going to say this dot x is equal to x, this dot y is equal to y. That's all that needs to have. Something simple. We don't even need to have a class, but why not? And we won't call it parts, we'll call it part. Now underneath that we can create the snake class, snake with a capital S, snake. It's going to have a constructor. It's going to take a game object, an x, a y, and how many segments we're going to start with. This dot game is equal to game. This dot x is equal to x. This dot y is equal to y. This dot, we don't need that. We'll say this dot can change. We'll use this value, set it to true. We'll use this value for our controls, so we won't be able to change or hit a change direction until we set it back equal to true. And we will also say document dot on key down is equal to function, passing in the event, and we will do the same thing in here. We'll say var underscore this is equal to this, so that we can reference it in here, and we can say this dot controls controller, we'll put it like that, passing in e dot which, so this will actually just be the key. In that function will be controller here, passing in the key. Alright, so we'll get that one ready. We won't put anything in there now. Next, let's actually add the segments. So we need another value. Let's put this stuff down here. Come on. Alright. And we're going to create a loop here, but we're going to say this dot parts is equal to an array. And in here we'll say var I equals 0, I is less than segs or seg, and I plus plus, and we're going to push some segments or some parts into the parts array. So this dot parts dot push, and we're going to create a new part at x minus 1 or minus I, or x, yeah, minus I, and then y. And that will just add some parts to our snake. Next thing I also want is to create the add parts function. So add part, and this will add a new part to it. So if we eat a piece of food, then we add another piece to the snake, and that's easy enough. Var last part is equal to this dot parts at position this dot parts dot length minus 1. So we're going to get the last part, and we will just create a new, or push a new part into the parts array. Parts dot push new part at last part dot x and last part dot y. So now we've just added a part to our snake, and I think this will be the last function, the update function, and we will loop through our parts and update them to the position of the part before it. So to do that, we'll say var I is equal to 0. No, we'll say var I is equal to this dot parts dot length minus 1. We're going to start up at the last one and work our way forward, and you'll see why. And then I is greater than or equal to 0, and I minus minus. In var part, we're going to reference part as this dot parts at the index of I. If I is not equal to 0, meaning it's every other piece besides the frontmost piece, we'll run something. We will actually say part dot x is equal to this dot parts I minus 1 dot x. So we're going to move these pieces to the position of the piece in front of it every update. That way it will look like they're trailing each other, like they're, one piece, one snake. Also, we can come in here, and if this dot x is equal to part dot x and this dot y is equal to part dot y, we're going to assume that a piece other than the front piece has collided with the front of the snake, and we will run a final function which will be die. So it'll say this dot die, and for now die will just this dot parts is equal to a blank array, and we'll have no parts anymore, thus causing the game to end abruptly. If we are the first piece, we're just going to set that to the position of the snake. What moves the snake, you ask? Let's come back up here and create x speed. Set it equal to 1 to start, and this dot y speed will be equal to 0. Alright, so in our update, we'll say this dot x plus equals this dot x speed, and this dot y is equal to this dot y speed, or plus equals this dot y speed. If this dot x is less than 0, then this dot x is equal to 0, so that we don't go past the boundary. If this dot y is less than 0, this dot x, or this dot y, is equal to 0. And we'll do another one. If this dot x is greater than this dot game dot width minus 1, then this dot x is equal to this dot game dot width minus 1, because we're dealing with indexes, or starting at 0, so it, the length or the width is going to be 1 more than the actual amount of grid pieces. And we'll do the same thing with the y here. And make sure we do it here. Alright. And the next thing at the very end, regardless of if it's 0 or not, we want to say this dot game dot grid dot fill grid, and we want to fill the grid at part dot x and part dot y. And so we're updating by x speed, and we should be able to come down to our game right under food, say this dot snake is equal to a new snake, passing this, and we'll put at 5 on the x, 2 on the y, and we'll start with 3 body segments. And we will update this dot snake before we update our grid. Let's see what kind of errors we have here. Okay, so it looks like we are not resetting the value of the node back to false. GP, we are just not setting it in the right spot. We need to put this GP.value right here. That will cause it to... Alright, so if you look, it dies. I mean, we get an error, but essentially it dies. So that's what we want. Next thing we want to do is add a segment when we hit food. Let's do that last. So first we will actually set up these controls, and we'll try to make this really fast. So if key equals 37, that means it's going left, and this dot y speed is not equal to 0, so it has to be going up or down for us to be able to go left or right. So in this case left, and this dot can change. So we have to be able to actually change, and we'll set this dot can change equal to false here. And then this dot x speed is equal to -1, and this dot y speed will be equal to 0. Alright, this is the kind of the concept for all of the keys. In the update function at the very end here, we can say this dot can change is equal to true again. So at the end of the update, we can actually then press the button again. But we do have to wait. That way we can't like go up and then back right before we update and then end up smashing into our body. So this control scheme here should allow us to control the snake but not hit ourselves, really easy. We can't just go backward and run back into our own body. Alright, so 37, 38, 39 is right, 38 is up, and 40 is down. So since we're going right, this is the same. The only difference is this is 1. Now all this is going to be different. Y speed gets changed to X speed, and 38 is to the right, or sorry, 38 is up. So Y speed goes negative, and X will be set to 0. And let's see, -1, -1, and this will be Y speed, and this will be X speed. And this needs to be X. Save that. Let's see if we can move our guy around. So as you can see, I can go left and right, and it doesn't do anything unless I'm going up or down. Same thing with up or down. Alright, so we're able to move. The final thing to do is go to the update of our game, and let's just do the if for if we hit a piece of food. So if this dot snake dot x is equal to this dot food dot x, and this dot snake dot y is equal to this dot food dot y, then they must have collided and we must have ate it. So what we do is say this dot food dot place food again, it'll move the food, and then this dot snake dot add part. This will add a part. And lastly, we also want to say this dot score val plus plus. So we want to increase our score. Alright, let's see if this runs. So our score is not increasing because we didn't put the right name. Alright, let's see if this works now. 1, 2, 3, and as you can see, our snake is getting longer every time we hit a piece of food. Our snake gets longer. Ooh. It's a little fast, but you get the idea. We did it in basically 30 minutes. The game of Snake using classes. Yeah, and ended up being about 185 lines, including spaces. Let's do this again sometime with a different game. Maybe we'll do another old retro type game. But if you like this speed version, just let me know and I'll keep busting some of these out. They're pretty fun.